Solving a system of equations by elimination. So when we use the elimination method, we want to make sure that both equations are in standard form. So your x's are stacked, your y's are stacked, equals your constants. Okay, we're going to use the addition method. So if I was to add these two equations, this is 1x and negative 1x. If I add 1x plus negative 1x, they cancel. 2y plus 5y is 7y equals 10 plus 4 is 14. At this point, I should only have one variable. Divide by 7 on both sides, y equals 2. That's half of my answer. Recall, the answer to a system of equations is where the two lines cross each other, and that should be an ordered pair. So we have half of our ordered pair. We have the y value. Then to find the x value, we're going to take this 2. We're going to plug it into one of the x's. It does not matter which one. I'll go ahead and choose the second equation. Negative x plus 5y, y is 2, equals 4. Negative x, 5 times 2 is 10. Subtract 10 on both sides. So I have negative x equals negative 6. I have to get rid of that negative, so divide by negative 1. So x is 6. That goes in my ordered pair. 6, 2 is my final answer. Remember, this is where the lines meet. Number 2. Okay, I'm seeing that they're both in standard form. My x's, my y's, and a number. If I add these right now, nothing will be eliminated. So we want to find the easiest term to eliminate. If I notice my y terms right now are opposite signs. So I'm going to think, can I make this 2 into the opposite of a negative 4? How do I get a 2 to become a 4? I multiply it by 2. But I have to multiply the entire equation by 2. So this becomes 10x plus 4y equals 32. Then my second equation, I have the negative 4y. I don't need to adjust it at all. So my goal by doing this was to eliminate the y term first. Now if I add these two equations, 10 plus 3 is 13x. 4y plus negative 4y cancel. 32 plus 20 is 52. Divide by 13. X is 4. That's half of my final answer. And go back and plug that in to either of the equations. If I plug it in here, that's 3x. But instead of x, we're plugging in 4. Minus 4y equals 20. 3 times 4 is 12. Subtract 12 on both sides. Negative 4y equals 8. Divide by negative 4. Y equals negative 2. So the one point where the two lines meet is 4, negative 2. Number 3. Okay, the first thing I notice is that the second equation is not in standard form. So first step is get both equations in standard form, which is where you have something x plus something y equals something, or ax plus by equals c. So I want to take this 3x, bring it over to the left. So I'm going to subtract 3x on both sides. Rewriting, that was equation 1, equation 2. Equation 1, leave it as it is, it's already in standard form. Equation 2, now I'm going to write my x term first, negative 3x, then my y, plus 2y, equals negative 9. All right, here's the new equations I'm working with. If I add them right now, nothing will be eliminated or cancel out. All right. Now I'm thinking there's no easy way to make a 3 a 4. There's no easy way to make a 2 a 5. So I'm going to have to manipulate both equations. So I'm going to have to multiply both equations by something. Let's eliminate the x's because they're already opposite signs. 3 and 4, their least common multiple is 12. So I can get the 4 into a 12 by multiplying it by 3. I can get the negative 3 into a negative 12 by multiplying it by 4. So my new equation 1 is 3 times 4x is 12x. 3 times 5y is 15y. 3 times 35, do not forget to multiply each one. That's 105. New equation 2. See if you can pause the video and solve it from here. Add these together. 15 plus 8, 23y. 105 plus negative 36 is 69. Divide by 23. Y equals 3. Let's have my answer. Now I'm going to take this 3, plug it back into any equation. I'm going to go ahead and plug it back into one of my originals. 4x plus 5y, I know that y is 3, equals 35. 5 times 3 is 15. Subtract 15. Divide by 4. So my ordered pair, my solution to the system is 5, 3.